Welcome back to the lesson. My name is Mr. Wong, and we are looking at writing and balancing chemical equations. So, the slight difference between this lesson and the previous two lessons is we're focusing on writing the equations as given to us from the word equations rather than being given the symbols to begin with. So, let's just start off. The way we balance chemical equations is based on a law, so a chemical law or scientific law known as the law of conservation of mass. What we know from the law of conservation of mass is that the total mass before reaction must equal to the total mass after the reaction. Okay, what effectively that tells us is the number of particles or the number of atoms should be the same before and after reaction. Okay, that's what we're looking into, and that actually governs the way we balance chemical equations. So move that down. So the next thing we go to is understanding the rules of writing chemical equations. So let's look at some of the rules first. Rules of writing chemical equations. Okay, and this is obviously basing off the worksheet you have on my left here. So the first thing we need to acknowledge is when it comes to writing chemical equations, you need to look at the word equation. So based off word equation. That's given to us already, okay? At least in the examples we're going to go through. Next part is writing the chemical formula. So writing the chemical formula of the substance. That includes our reactants and products. Once you do that, write the subscripts or write the states in subscript form. So there's 4 in total. Now differentiate by color. So firstly we have solids, and this is if it's solid at room temperature, right? So state of matter in room temperature. Okay, we have our solid, we have our liquid. Generally speaking, we don't really write anything as a liquid unless it's a pure liquid substance. Like if we say H2O water, we write it like so. If it's solid, we write, sodium as a solid. We have a gas, that's lowercase g. So it could be oxygen, that's a gas. And then we have the last one, which is known as aqueous. And that's written as AQ. and that could be, if sodium chloride was diluted into a solution. So this AQ represents a impure liquid substance. So if it's in a liquid form but it's not pure, we call it an aqueous solution. And then obviously last step is to balance the chemical equation. So balance formulas. By changing coefficients. Remember, the coefficients are the numbers at the front of the equation. So that's what we have there. Okay. All right. So let's go into some examples and hopefully it'll give you a bit more context of how to do these questions. I'm going to do example A here. So we have hydrochloric acid is added to solid magnesium hydroxide, producing water and the soluble salt magnesium chloride. All the compounds you really need are given here, okay? Or you can look at the periodic table. Let's start. So the symbol for hydrochloric acid is HCl. That, according to the question, was reacted to solid magnesium hydroxide. So magnesium hydroxide is given here. So Mg bracket OH2. That will form water, H2O, plus our soluble salt. So what you can see here, it says soluble. Soluble means it is dissolved as a liquid. So magnesium chloride. So it's in a liquid form there. Okay. Next thing we need to work out is the states that they're in. So sodium chloride is a salt. It's diluted. Okay, any acid that we're dealing on, not sodium chloride, hydrochloric acid. So any acid is diluted in our reaction here. So it's always going to be AQ. Another one that will be AQ is the magnesium chloride because it says it's a soluble salt. So that means the salt or magnesium chloride is dissolved into water. So this is also going to be AQ. Okay. Obviously, I'm missing some space here, but try and fit it in the same spot. We dissolved it in water. Now, water dissolved in water is, just water. So that's a pure substance. So it's a liquid. And then we said that magnesium hydroxide is solid. So that's a solid there. So that's everything we need. The next part is making sure we've balanced the chemical equation. So when it comes to balancing, set out your table, your balancing table, and the idea is very simple. You want both sides to be equal to each other. Okay, that's the whole point. Check for time. Okay, so we have one hydrogen here. We have one chlorine atom here. We have one magnesium. And then we have two OH groups here. Notice how I don't try and split up the oxygens. Just for convenience, I can do it like that. Or if you like, you can split it up into the individual, hydrogens and oxygens here. But just for our own sanity to start off with, let's just split it into components like that. Okay. The next one we have is water. So we have two hydrogens, one oxygen, one magnesium, and two chlorine atoms there. Okay, so let's just sort out what we have first. Firstly, we want to balance out the ones that aren't balanced. Obviously, that's pretty straightforward. So let's try and pick something that's easy to do first. Now, notice how we have hydrogen here, and we have hydrogen here and hydrogen here. Now, the general consensus is never balance. So never balance an atom that appears twice on one side first. So you can see how we have two hydrogens here and only one hydrogen here. Never try and balance these two hydrogens first, or that hydrogen there. The reason being is it does make it a lot difficult to track where everything else is. So generally speaking, you always find the carbon that only, or the atom that only appears once on both sides, and then you sort the ones that appear multiple times later on. So we have our chlorine here, we have chlorine here. Let's solve for chlorine first. I have two chlorines here, so I need 2 on this side as well. So I'm going to put a 2 here. So it's going to be 1 times 2. I have 2 chlorines here. Cool. Okay. Magnesium is balanced, so that's all good. So magnesium is balanced. Chlorine is also balanced. Now, we have 2 oxygens here. Okay. So, let's balance the oxygens first because it only appears once here. Okay, so if I have 2 on this side, I'm going to give myself 2 on this side as well. So I have 2 here. Okay, so what that means is I have 2 oxygens, which is 2. This here, let's just move this hydrogen. So let's get rid of that hydrogen, write it as 2 originally. So we have now balanced out the oxygens. Okay, so I have 2 oxygens on both sides. All right. Now let's count up the total amount of hydrogens I have in total now. So on this hydrogen here, I have 2. On this hydrogen here, I also have 2. So in total, I have 4 hydrogens on the left-hand side. I have 2 hydrogen molecules, or 2 water molecules, sorry. That means I have 4 hydrogens in total. So 2 times 2, I have 4 hydrogens now. If you have a look, our equation is now balanced. So that's tick, tick. So everything's balanced. We have the right units of states. That's what we're looking into. So that's how you would do this one here. Okay. Let's try another one. Okay. And this time, hopefully, I'll keep it within the same one. So we'll do B. So we have nitric acid. According to the table, nitric acid is HNO3 plus calcium carbonate. We get carbon dioxide. We get water. And we also get, hopefully it fits, calcium nitrate. Ooh, it won't fit. So I'll just rewrite this one down here. Ideally, you should write it on the same line, but obviously write a bit too big, so we'll just have to leave it as it is. Okay, so that's what we have. Next is write out the states it should be in. So acids are always diluted, so AQ. Calcium carbonate, that's a solid. Bubbles of carbon dioxide, that would imply it's a gas. Water, pure as always. And then a soluble salt, AQ. So that's our states. Alright, next is balancing off our chemical equation. Now, here's a little trick that I want you to consider. I tried in the first one, but it didn't work out because it didn't happen. But notice how NO3 is on both sides, right? It appears twice, okay? So let's just count the NO3 as its own entity, just only for the case where you see it again, okay? If, for example, the one I saw here where I had OH, but OH doesn't appear again, don't try and do it like that. It'll just confuse the heck out of you. But if it does appear, if the polyatomic ion does appear again, right like this, it will make life so much more easier for yourself. Right, the amount of hydrogens, right, the amount of calciums, and then the amount of carbons, and then the amount of oxygens. Notice here, I'm not going to write CO3 because CO3 doesn't appear again. So I'll just leave it be. I'll leave it as it is, just so I don't confuse myself. Or more precisely, I don't want to confuse you, so we won't want to do that. On this side, we have 1 nitrate. On this side, we have 2. On this side, we have 1 hydrogen. On this side, we have 2. Carbon 1, or calcium 1 there. Carbon is 1. Oxygen is 3, if you count the 2 here and the 1 here. We have 1 carbon and 3 oxygens. Okay. So if you look at the issue we have here, clearly we don't have enough nitrates, so NO3, and we don't seem to have enough hydrogens. Okay. So first step, hydrogen only appears once, so we're going to balance this formula out first because these two only appear once on both sides. Okay. If I put a 2 here, I now have 2 nitrates, and I now have 2 hydrogens. That matches that. Tick and tick. Oh, whoops. This one, sorry. Don't know what I was doing. And that one balances out now. Tick and tick. Okay. I have 3 oxygen. Cool. I have 1 carbon. Cool. And I have 1 calcium. Cool. So that's done. Balanced. Okay, easy stuff. Well, good enough, I would say. All right. Let's go through a couple of, maybe let's try a challenge question as well, just for those who really want to give themselves a little bit of a go. Okay, so if you aren't interested in trying the challenge question, you can finish the video here, but if you are interested in the challenge question, by all means, continue on here with me. So we're going to use the example of F, and we have the iron metal, which is a solid, plus chlorine gas, which is diatomic, so Cl2, and then we produce iron chloride. Okay, now in this case, before I set it all out, iron, its valency charge is 2+. Chlorine has a valency of 1-. So if I crisscross the numbers over, iron would be iron 1 and then chlorine 2. So we can write FeCl2, shorthanded way because 1 are redundant. Okay, so this one here, it's actually balanced. Don't have to do anything about it. If I just write the states, it's done. You notice how in the question it doesn't say it's a soluble salt, so we can assume that it forms a solid. So iron chloride, and yeah, easy stuff. That one's solved there. We'll go with question I, which is sulfur dioxide. Remember your conventions in naming covalent compounds. We have oxygen. Oxygen is diatomic. And then we have sulfur trioxide. Okay, so this one's slightly different. You can see that we have 3 oxygens on the right, and we have 4 oxygens on the left. What I prefer usually doing, and you can see if that's to your liking as well, I prefer to always make the odd numbers even first. So make odd number even. So I'm going to make this into 2. So that leaves me with 6 oxygens here and 2 sulfurs here. On this side, I have 4 oxygens in total and 1 sulfur there. So ratio-wise, it's actually going to be quite easy here because all I have to do is put a 2 in front here. Then I have 2 sulfurs. 2 times 2 equals 4 oxygens. We have 2 oxygens here, so now I have 6. So now this equation here is balanced. Okay, so that's pretty much it with the challenge questions. Hopefully this video has helped you with writing balanced equations as they are. Obviously, the more difficult version of this would be you trying to write the formulas out without this little chart to help you here. So if you can write chemical equations without looking at the original formula and you can construct it by yourself, then, you know, top notch. Do consider doing year 11 chemistry then, if I consider. And if you can't do it straight away, by all means, keep trying, because once you get into the pattern of it, it does get a lot more easy to do over time. So persevere and keep trying. Anyhow, thank you for watching this video. Hopefully you found it useful. You can also search up all the other different videos on this channel. There are some chemistry ones, there are some physics ones that you might want to check out. But, you know, that's completely up to you.